So turning now to our program, today's theme is, as I said, innovation in a digital world. We are seeing changes within aerospace and outside of our industry as we are relying on technologies like digital engineering, artificial intelligence, machine learning, and autonomy to move aerospace into the future. At AIAA, we believe digital transformation is the fourth industrial revolution. So we are very excited to focus on digital innovation as part of the AIA R&D domain that Scott Faust is spearheading. Scott's insights have been invaluable to our team as he performs the SciTech executive producer in building this week's program, and especially driving today's emphasis. It really was his brainchild. Our speaker today will reflect on the ability for digital technologies to transform the aviation industry, from engineering and manufacturing to airline customer relations and passenger experience. I'm very excited to introduce our keynote speaker, who is Guillermo Jenaro Rabadan. He is with Acubed, the Silicon Valley Innovation Center of Airbus. Guillermo, as the project executive of the Advanced Digital Design and Manufacturing, or ADAM project, he leads a team that is providing a platform to drastically reduce product lead times and lower production costs. He and his team are uniquely positioned to identify and innovate on emerging technologies with collaborators in Silicon Valley and across the globe. He has 2 decades of experience in aerospace, many with Airbus engineering and innovation teams. He has led multinational teams in flight physics and research and technology programs, and worked in various areas such as flight controls and crashworthiness. On a fun note, he is an accomplished musician and is a piano grand amateur. I'm disappointed that we won't be able to hear his piano skills today, but that just means he's going to have to come back soon and play for us at some event. When he concludes his remarks, Guillermo will take questions from our audience, so please see the Q&A link on the screen to enter your questions or to upvote on a question that's been entered. And then for those of you on the virtual platform that are joining us today, very glad to have you, please go to the Q&A tab in this session. And so please join me in welcoming Guillermo Jenaro Rabadan to the stage.
Thank you, Marily, for the nice introduction. Dear colleagues, ladies and gentlemen, good morning. It is my pleasure to be here today talking about digital innovation. I think during the past 3 days, we have been learning about big challenges that we have in our industry. We have been learning about what organizations are doing to push the boundaries of our world. And we have been learning about money and what investors are thinking about the future. This morning, I'm going to talk about digital innovation. And the way I understand digital innovation is really to provide a tool and a capability for us to learn about the world faster, better, and in different ways. I think we live in an era of accelerated learning, and this truly excites me. I decided whether I wanted to study aerospace engineering or physics. I decided to pursue a master's degree in both of them, thinking that understanding the science and the fundamental principles and the applications was going to help me to build better abilities to solve complex problems. And I love that challenge. During my university time, I was learning 500 years of discoveries, successful experiments, beautiful theories, and all that during the course of 5 years. And that was accelerated learning, and that was a lot of fun for me. So after that, I started my career as an aeroelastician, developing aeroelastic models, methods, and running simulations across a large number of flight points, configurations, mass cases. And what I discovered is that that was such an interesting way to look at the reality and our products in different ways. I could ask any type of question to my model, even stupid questions that I would not dare to ask to my professor at the school. And then I would get in the answers and improving those models. And that was really a way for me to understand if my product was ready or not to fulfill its mission. After that, I moved to other areas of knowledge and engineering. But basically, I was doing very similar process to discover and learn and design things with the information I was getting for these digital tools. So I think digital tools is really about providing that capability for us to understand the world in different and better ways. This was in the early 2000s, and over the past 2 decades, so many things happened. And they were silent in the background, but today when we look at where we are in 2022, we have a couple of numbers that are very impressive and daunting. So we have, according to some estimates, 50 billion connected devices, IoT devices, which is 8 per people or per person, per capita in the world. This is really devices that generate data, consume data, but also provides us ways to interact with the physical reality. We have written, and we have around 3 billion lines of code that are today running to support the applications that we use in our daily basis. In terms of data, in 2022, we have created and consumed about 100 zettabytes of data, which is 1 followed by 23 zeros. That's such a daunting number. It's the square of the numbers of stars we have in our galaxy. And in aviation, if we look at our flying fleet, in 2022, we produce about 60 exabytes of data. On top of that, we have continuously reduction of cost of our computing capabilities or flight point operations per second, and we project that all of these dimensions are following exponential growth curves. So these tools are here and are going to be more powerful for us to solve our challenges. And then we go into the other side of the equation, which are the challenges we have to face. And to me, this is the biggest one, sustainability, or one of the biggest ones. I am very proud that Airbus is following a very strong commitment towards a roadmap towards decarbonization. At Airbus, we have very smart people looking at this problem in a very holistic way, because there is not yet a clear linear path towards the solution. We are looking at things such as different aircraft configuration types and the trade-offs between the different vehicles. Then we look at systems in the platform. Then we look at propulsion system. We look at energy sources. We look at infrastructure to make that happen, and operationally how this entire construct can work. But if there is something clear, it's the target and the goal that we have to deliver. And in order to deliver to these challenges, it's a must for us to use the best techniques that we have at our disposal. So I want to talk about some examples of things that we are doing at my home base, which is Acubed, Airbus's innovation center in Silicon Valley. And about Acubed, I'd like to highlight 2 things that for me are remarkable. The first one is the access of some of the best software engineers in the world that come with decades of experience in developing frameworks, DevSecOps, and also with a lot of experience in big AI machine learning problems, including infrastructure and software. Then we intersect this talent with aerospace talent and with the problems of aerospace, and what happens there is incredible. The second thing I'd like to highlight is the mindset and the culture. We find in the Valley, but I think this is really spreading all over the world, is this notion of discovery and exploration. Is the thinking that if I want to start solving a problem, I better build something quickly so that I can start learning about it, rather than thinking about what are all my options and which one is the best. Just start building, test it, learn from it, improve it, and iterate. So this mindset is something that, for me, coming from a more traditional aerospace environment, was a right. Has been a very interesting process for me to discover the powerful approach that this mindset brings. So I want to talk about a couple of examples. The first one is on the digital design and digital engineering realm. It's about the cabin design process. So tools to help us visualize cabins before we build them is something that we have had at our disposal for a long time. but a fully integrated framework where we are able to explore large design spaces, prune the space with a number of rules, and create compliant cabins, and then build domain analysis in an integrated way so that we can define the trade-off space for us to understand the objectives that we want to deliver, which include manufacturability, servicing, what is the cabin going to serve as a market and a passenger and density, what is the lead time that is going to take, what is the affordability, what is the sustainability of this concept. We can assess these in 1,000 different scenarios and build them digitally, so that when we go and build that physically, we know that we are building the right thing and that we are building it right first time, because we've done it many times digitally. So here I have a little video, and I'm going to speak over it. There is some background music. I think that will help for those which are still trying to wake up. So here, what is very important is to help the engineer with a very simple interface so that they can understand which type of trade-off he's running. He can prepare his aircraft, partition, and then have an engine that automatically is going to populate all these different options that you have in this large combinatorial space. Then you can assess them with a number of metrics, like variability, affordability, and so on. And then create domain analysis to answer those questions, like what is the acoustics footprint of this cabin? And that requires analysis and simulations. What is the other constraints, such as the visibility that we have in the cabin? And then you can build all this trade space for making a decision. But that's one part of the question. The other is how we can help our engineers to be empathetic with the customer and understand and visualize and feel the products that they are designing. And today we have such a good frameworks and tools for us to make that happen. This is one example. You can feel you are walking through a cabin. Maybe you don't like this layout. You want to change a different layout. You want to change to economy class. You want to change the lighting, you want to change the colors, you might be willing to change the material. And it's really now about experiencing that and building that empathy with the customer or even with the passenger. And that's so important for the decision to have this, the decision makers to have this holistic understanding of the product that allows for science, but also for experience. The second example, before the second example, behind all that, there is obviously a strong engineering process. So you need to be able to define this user interface, which is simple, but also enough to design all these different cabins. Then you need to understand all your rules, the compliance, the regulations. You might have around several thousands of rules that you have to meet. So you need to prune this design space with all that information that has to be machine readable and automatized. Then you have an engine to generate cabins, that you can filter them so that you do the heavy analysis, such as acoustics, in those that are already some more promising for you. And then finally, you get your dry space to make it. The second thing, which is very important and a key to the success of these approaches, is to have the right architecture. It has to be modular. Things are evolving, so you want to be able to swap things around as they evolve. It has to be composable. You might inject some more models from, for example, things that you are learning through machine learning from your operational experience, and then it has to be extendable. So those models might grow as well in size. It's important that you have the right architecture to make this scalable. The second example I wanted to talk about that we are developing at Acubed is around the program Wayfinder. So we develop autonomous flight and machine learning solutions for the next generation of aircraft with the goal of increased safety and assisting pilots so that they can focus in different tasks, in the critical tasks. This basically requires for us to do two problems. One is to solve the perception problem. How do we make the aircraft aware of its environment? And the second problem is the decision making. How the aircraft can react to the environment that perceives. So those require, for these problems, we develop machine learning algorithms that require data collection and data management at a scale of petabytes. So this requires infrastructure and know-how that is critical for this type of new approach to be successful. Then this new approach also means that you have a highly high input, high output state, and then you have to think about how you make your high input in this different approach to cover all the conditions that you expect to be encountered in the lifetime of the aircraft in operation. So in order to extend and augment the data coverage, we've built a digital twin to create synthetic data and augment the data sets that we collect in flight. So this is a way to really accelerate the learning process of the algorithms. I want to give you some example of that, where in the upper left corner, you can see a real flight captured with our image system, imaging system. You see the runway is identified by the system. And in the bottom part, what you see are digital twins. So we recreate that environment with simulations, with the real physics behind and optics to see everything that the camera is going to capture. And we can play with different things such as sunlight, weather condition, day versus night. We can also add obstacles and recreate situations that would be extremely hard and expensive to do in an experimental setup. And then you can see the result there. So for us, the developments that are happening in the tech industry and also in the autonomous driving industry is the starting point. They've learned and figured out a lot of problems similar, so it's our starting point, and then we take it from there to adapt to our specific environment in the aerospace and our specific applications. The third example I have this morning is around air traffic management and unmanned traffic management. So we have created the digital twin of the airspace to provide a sandbox for our smart engineers to create the future of air traffic management that is not only safe and efficient, but would be able to accommodate a diverse ecosystem of flying products, including things such as air taxis, delivery drones, and so on. So we have built capability, which is based on realistic models and advanced simulation tools for decision makers to explore all these technological trends, standards, and regulations that can make this future need possible. And it's incredibly important that we make it and have it ready, because as we speak, there are companies building innovative air vehicles, and we have to have our airspace ready to integrate those. The way I characterize this is like a video game where you sit and then you can play with different scenarios. You can tune your parameters at different type of vehicles, different densities, different rules, and then the one who finds the rules and the standards that lead to an easier, better, and integrated ecosystem wins the game. So it's really about engineers trying to understand and learn from these digital tools. How can we make possible this future that we see coming? So I wanted to show a video about this concept, which basically explains it, but also shows some images of different tools. So please bear with me.
Unmanned traffic management, or UTM, is a critical enabler for the future airspace. As the industry begins to operationalize UTM, it must be done safely. We believe that simulation-driven validation and verification is critical to the safe deployment of UTM. Safety assurance is also critical to accelerating the necessary and scalable deployment of UTM. At Airbus UTM, our approach to accomplishing this is to offer simulation as a service. We have opened our simulation environment to authorities and industry partners. With real-time simulations of, for example, active deconfliction, we are able to illustrate the fundamental building blocks necessary to ensure vehicle flights are safely planned. With fast-time simulations of elements such as deconfliction for complex operations and in high-density traffic areas, we're able to rapidly illustrate and analyze potential issues and outcomes. As the airspace of today and the future becomes increasingly complex, with more vehicle types and mission profiles, our work at Airbus UTM is vital to ensuring our industry maintains and improves upon its rigorous safety standards. Simulation as a service is an essential route to building safe, integrated future skies.
So we have seen 3 examples of digital innovation, which we have figured out a lot of things and we have learned a lot from them. The question is how we take from some examples, and also I'm sure that you in your organizations are doing also great examples about bringing these ideas towards solving certain problems. The question is, how do we go from a number of examples on different domains towards a fully digitally transformed industry? That is a hard question that we have to solve together, and we still have to learn a number of things. I would say many things. But we have been doing this for some years, so I would like to share my experience and some of my observations that I think are critical to make this successful at a scale. The first one is complexity. It's very easy to get trapped in complexity. You can record every data set possible. You can try to build every domain in your simulation. And you end up with something that is very hard to understand, is very hard to maintain, gets a lot of technical debt, and becomes probably not very useful. So the question is, and my encouragement is, simplify from the beginning. Start with your idea, think first principles, then when you are midway, try to find ways to simplify it, and when you are done with your project or your product, look at it again to see whether you can simplify. It's going to pay off. And the first reason for me that justifies that is eventually you build all these tools for people to use and to solve problems. If it is simple and they can understand it, they are going to be able to use it in a much better and faster ways. But also, they are going to be part of your development process because they understand the mission you want to accomplish. Simplicity is such a beautiful concept, and we are so much compelled to them. So simplify as much as you can. The second thing is multi-generational and multi-teams. So for some, these transformations require people from different areas of expertise, but also different walks of life. We talk a lot about digital talent, generation XYZ. Well, at the end of the day, you need people that have fresh views and energy and is acquainted with certain frameworks, and people that have the experience and know why things are what they are, what things we tried in the past and didn't work, but not that they didn't work, why they didn't work, so that we can try it now with more informed approaches. And eventually, for me, this is to formulate an inclusive language where you have a group of people solving a problem and they share a goal and a meaningful purpose. So I believe it's very important to use the language the proper language to get people involved into these transformations. The third one is this hardware versus software. I hear a lot people saying that all these agile frameworks, they are really good for software, but they don't work in hardware. Our aerospace products, they have a lot of hardware in the loop. But I would make 2 observations here. One is our products are becoming much more heavy in terms of software. So software becomes a much important component to them. And the second thing is that we have examples around us in the corner, in the valley, of companies that are building hardware and are using agile approaches to build this. And they go very fast. And at the end of the day, what they are doing is the same thought principle. They want to solve a problem, they have an idea, they start building it, they test it, and they learn, they iterate until they get the right product to market fit or solution to problem fit. The fourth observation is about risk management versus zero risk. So zero risk incentivizes our talent to repeat the processes that they know they work and deliver something, even though they also know that they are not efficient and they are long and so on. So really helping and empowering them that are at the front line to understand how they can make their process better and to have the tools to analyze what is the impact of these processes is extremely important. With no risk, there is no innovation. But the risk has to be managed, so we have to be very diligent in managing the risk. I hear also in this conference a lot about risk and taking more risks, and I think that's exactly the spirit to unlock innovation. But also we have to recognize that we need to find methods to manage that, and it's possible. This is what we are doing at our innovation center. Then extended ecosystem. So this industry is built on partnerships. We call them suppliers, we call them OEMs, we call them airlines, we call them universities, we call them research centers. But we are working together toward the goals of making our vision of the industry working. So it's very important that if we want to undertake these digital transformations, that we have some shared understanding about either standards or how do we share digital information in a way that we can understand it better, but also that we can share with our systems so that they can consume it very quickly. There seems to be economic incentives that in the short term might look like sticking to my own standard has some advantages at this point. But I am fully convinced that this is really a long-term game, and there's going to be win-win solutions because we will make our industry better and we will solve challenges that are extremely important. So long-term value thinking is one of the key elements for me for these transformations. And finally, I'd like to talk about the accelerated learning approach again, because all these tools, they have a purpose. We do them because we want to solve problems, and we want to solve problems with our talent that want to learn. I hope I'm connecting with all these curious minds that we have all inside, that they see the joy of getting tools to play with different scenarios and to get the learning out of it. It's about empowering our talent, and also it's about upskilling the people that have certain experience and want to learn other topics, such as software development, for example. It's important to support them in their journey so that they can learn and they can build this vision together. So those are some observations that I think are useful. It clearly has been useful in our journey and in my journey. And as I approach to my conclusion, I'd like to make a couple of statements. So we have seen that we have this amazing resource at our disposal that is growing, is all this digital technology that is pushed by the computer industry, but also is pulled by the other industries that are learning how to use them to create value. Then we've seen we have very important challenges that we want to solve and we have to solve. And then we've seen some examples, concrete examples about how this can be embodied in real value-creating applications. And finally, I've gone through some of the learnings and observations that I believe are there to support the large-scale transformation. Eventually, what I'd like to say is this is really about having fun doing this together. And I think at Airbus we are doing our part, pushing this boundary forward. And I'm very curious to see and to learn about what you are doing in your organizations and in your teams. And I think we have today a very good day to go about these conversations. Thank you for your attention, and I'm looking forward for your questions.
Thanks, Guillermo. Definitely can see how Acubed is the innovation engine for Airbus. So now Guillermo will respond to some of your questions. Please go to the link shown on the screen, or if you're joining us on the virtual platform, go to the Q&A tab so you can submit or upvote a question. I would like to start with a few questions that I have for Guillermo. And the first one is, and it's really related to the success of digital transformation and programs. Why do you think it is hard, or why do some digital large-scale projects don't deliver the value with the high expectations, or even sometimes could even fail completely? Why do you think that's so?
Yes, I think we read and hear a lot in the press and other publications that a lot of companies, they are not happy with what they are, and they wanted to be more advanced in some of these transformations. I think there are a few critical conditions that we have to have for successful transformations. One is to have, from the top of the company, at the executive management level, an agreement upon the strategy for the transformation. It's not enough that this sits at the technology side or at the CIO, DTO, or digital transformation office side. It has to be agreed upon all the different functions of the company and what use case you want to implement. Second, you need to get inspiring leaders for some of these transformations that are very hard. You need to have people that are able to remind the purpose and attract top talent to make those happen, and this top talent is really diverse in many ways. Third one is it has investments that have to happen, and those investments, they happen in the people side and in the project side, but also in the infrastructure. Some of these techniques require continuous upgrade, moving to the cloud, or upgrade your data center and your systems. And you have to do these investments in parallel with the legacy systems that you have to run your business continuity. So it's important to have that investment plan agreed. And finally, the fourth element, which is as important as any other of them, is the execution excellence. You have to be excellent in execution, making sure that you empower the front lines so that they can improve their processes, they can implement those, but at the same time there is a synchronization point and there is a thread towards the vision. It's very important that you are diligent in that execution and then you close the loop. It's like any other problem, you are learning new things as you go, so there is always this feedback loop to rethink your strategy and whether there are things that you want to change or improve or subtract.
Yeah, I definitely agree with you. I think involving all functions, having that senior management commitment, the technology investments, and then the execution excellence, I think are a really good recipe for all of us to remember. So thanks for that answer. My next question, obviously technology innovation involves disruptions. So what do you see as the next big disruptions in digital technologies?
That's a great point, because I see a lot. When I was talking about exponential curves are on the technologies that we know, and there are at least three I would like to highlight that are coming our way. So there is a new refreshed way for artificial intelligence, and I think we all read in the press things like the advanced models for the GPT, the things that are able to do and how much faster you can train them. I think that's going to help us to learn about how to use AI in new ways. The second is quantum technology and quantum computing. I see the hardware manufacturers, they are making very good progress in the last couple of years. They actually are executing according to their roadmaps, which is excellent, which is really good. And I believe that we are starting to be ready to have some things that we can use. The question in the quantum computing is there is still a lot of technological risk, but there is no business risk. So if you get a quantum computer, people are going to use it. There is such an advantage. Other technologies like Web3 or blockchain, they have some technology innovation aspect, but also they have business model innovation and risk. We need to learn how to use those technologies. In quantum, if you get a quantum computing there, you are going to use it. So I'm very excited about the quantum computing and what's coming. Then the third is the VR, AR. So we see the digital tech industry investing heavily in things like the metaverse, virtual reality, augmented reality, ways for our body to interact with the digital world in much more ways than our eyes or fingers. And I think there's going to be a lot of spillovers from those advancements into our industry that we will use in many, many verticals, from engineering to customer services to marketing and all these things. So a lot of disruption to come.
Yes, three good examples. And I I like the comment about looking at disruptions through whether it's both a technology risk and or a business risk. Through that lens, I think is very insightful. You know, you mentioned standards in your talk, and you were talking about how supportive you are, and certainly that warms my heart as president of NCOSI, because in the system engineering, digital engineering, architecture domain, we of course care a lot about standards as well and try to do our part. So my question to you is, can you give a specific example of standards and how you feel like it would be very helpful to digital transformation?
Yes. So, by the way, I think the work you are doing at NCOSI is great, so congratulations, and thank you for pushing those ideas. I know it's not easy. So, yeah, standards, again, if you have a standard, you can make things much smoother and faster. The advantage of the standard is very clear. The question is how to get there. And you have to involve a lot of people with different views, and to me, accelerating that process is very important. The trade-off space is very important. And the second thing is this notion of complexity again, because when you have a standard, you always are going to find corner cases that are not feasible in your standard. So you are attempting to improve the standard and to grow it and to grow it, and at some point you have a lot of different concepts, and maybe you use 5–10% of it. So there is a lot of overhead for people that want to solve, the majority of people that want to solve certain problems. So it's very important to be mindful about how you progress a standard. And I think, again, you are doing a good job. For example, at Airbus, we are having a lot of experience with SysML, which is for our MBSC efforts. And I think we are having a very good experience because it's a way for us to share across domain and across company information. So SysML is one example of a very good standard, and I know SysML 2.0 is coming as well. So hopefully it's going to make it better and
Definitely.
and easier.
Yep, working on SysML v2 now and always trying to improve on that standard so that it really becomes very widely used. So thank you for that. So we have some questions for the audience. I'm actually not surprised based on the upvotes to see what the most popular question is. And it is, with this increasing digital reliance, are you concerned about cybersecurity?
Yeah, cybersecurity is one of the conversations that everybody's having these days. Yeah, I think concern is, rather than concern, I would frame it, it's something that we have to consider, knowing that it's much more information in the digital world that is exposing information about your company or your product or your project. Second, you are moving to things like the cloud. And, but also we are learning and investing heavily in cybersecurity across the globe and across the industry. So for example, the cloud, which seems to be a risk because you have things out there, is making very good progress to build intelligence, because at the end cybersecurity is the game of intelligence, to build intelligence about detecting patterns in some areas of the world or in some industries, and then basically protect against those throughout the entire layer of applications. So yeah, cybersecurity is clearly a focus topic, but I don't think it's an excuse not to leverage, because again, we have challenges that the only way we are going to solve them is we are able to transition digitally. So we just have to add that in our effort to build solutions to that.
This is a little bit of a related question to that first one, but with all the data and information, what approaches do you recommend to assure that the data is correct and trusted? And how do you certify the software tools and data that you use?
Yeah, it's a good question. So yeah, you can collect a lot of data, and very often you start building a project and you find out that the data you've collected is not the right quality or doesn't have the right integrity. So I believe the answer to that question is, now that you know you want to solve that problem, from the beginning when you start your project, you have to look at it. You need to understand which is the data quality that I need to solve. Do I have access? Do I have the right sensing instruments for that quality? Second, I need to understand in my device and my entire pipeline, is the data integrity there? And I think there are a number of frameworks that support you to get in that process. And then the other thing is, once you build all this automation, then how do how do you think about them in a way that you can certify them and get full confidence that they are going to work in all possible scenarios? So I think that we have been doing a lot of certification based on testing and data, so we have experience doing that. And then there are some new approaches with some more advanced machine learning models and AI that are part of ongoing conversations with the regulators because they see the power of that. And we need to understand what do we need to evolve in our regulatory framework and the way we have these conversations and the skills that we have, but also that the regulators have, to make sure that those are at an equivalent level of safety and compliance as the previous ones.
Very interesting about the evolving to AI techniques to help you with that. You had mentioned that, why you're especially excited to work at Acubed is both the software talent, the expertise that you have, kind of the world class, and also the mindset that they bring, this innovative mindset. But we have a question related to attracting top talent. So, sometimes aerospace companies that are represented here have sometimes struggled to attract top talent in software development because of compensation gaps between tech companies and aviation companies. Has your team encountered this issue, and do you have any advice for us to improve recruitment in software development?
Yeah, that's another great question. So I think the question is how do you attract, why people come to work for you in your company? And I think we have a number of good ideas to understand that process. So one is that people are driven very often by the purpose of the things you want to do. And in our industry, we are doing relevant and important things. We have people to connect, to travel, to visit their families and places, and to provide security. So I think they connect with the purpose and the mission, and this is what drives many of their decisions. And the second element to that is, as soon as you start having smart people bring other smart people because they see the energy and they see that everything becomes possible. So I think there is a lot of feedback loop in the organization that you create. And yeah, if you are driven purely by financial purposes, then maybe it's not even tech company. Maybe you want to go to Wall Street or something like that. So yes, there are people that have different priorities in life, and then you cannot attract everybody, and probably you don't want to attract everybody. But people with passion for aerospace that want to make a difference in this industry, and they have the skills and the willingness and the passion to express it, I think those are the ones that come to us and create all these things that you've seen.
Yeah, good point about both the mission as well as the feedback loop on the passion that they bring to it. In kind of a related question, and of course we have a lot of young professionals and students that are here. So you talked about accelerated learning as one of the key things. So given your accelerated learning experience, what advice do you have for young professionals and students of how to approach learning over their careers?
That's a very good question. I don't know whether I'm the right one to answer that question, but what I can tell you, I've learned a lot by making mistakes, and it took me some time to realize that making mistakes and recognizing them is not such a bad thing. I think in the early 2000s it was more difficult than now. Today a lot of people talk about failure, and if you didn't have a failure in your life, you are not successful. So I think it's really recognizing that making mistakes and trying things is the best way to learn. And the biggest the mistake, the biggest the learning. Like if you make a mistake in a very public setting, you are going to remember that learning probably for very long. I also think that the education system is changing. I don't hear, nobody is anymore asking stupid questions. When you say, oh, this may be a stupid question, then your professor is going to be the one saying that there is no stupid question. So I think there is this recognition that it's not really about pride, it's really about express your curiosity, and the bigger your curiosity, the more you're learning. So this is maybe my advice, is let your curiosity to be expressed through questions, through trials, and then learn from all the mistakes you make, and also learn from all your successes and enjoy them.
Yeah. Kind of while we're talking about learning and knowledge capture and management, sometimes when we're developing things and the associated knowledge that comes from all the work that you're doing, sometimes we don't get it transferred to future generations, so that knowledge management, knowledge capture, and passing it on. How do you ensure that lessons learned from the studies you're doing, the simulations you're doing, become readily available from generation to generation, or as people continue to join at your company?
Yeah, another great question. So. One thing I believe that one of the things that the tools in the digital space bring is access to collaboration. You can write a Google Docs collaboratively, your peers in any part of the world, and you can share that information instantly. So I think we have better frameworks today to share information and to capture information. Then second, the best way to learn and to get the experience and the mentoring is when you are together working in a project. So I think, or with a specific common goal. Sometimes and I have experienced some cases where there is a knowledge transfer by itself without a concrete problem to solve or product to develop, and this is much harder, it's drier, you see less the purpose of what you are doing. So try to find ways to have a team working with common goals. I think it's a catalyzer of that knowledge capturing. And then the third thing is 100% knowledge capturing is probably an utopia and utopia that you are not going to get. So where is your bar? What are the things where you really want to make the effort because you think are so critical for your company, for your products, and for the future that you have to make sure you capture 99% of that, and then find ways with tools and the specific collaborations and projects to make these things happen. Those would be like my observations around that.
Yeah, your point about the ones that people then will actually use are probably the ones that are easier to do the passing on from generation to generation because it really has an impact. So yeah, definitely. So aircraft design will always be dependent on experienced engineers and passing lessons learned to future generations, which of course we just talked about. How successful have you been across your engineering disciplines to adopt new model-based engineering and MBSE practices? You had mentioned about SysML, for example.
Yeah, we have a large, I think now we have a baseline and a common understanding in the company that MBSE provides so much capability to build better things and try them and de-risk them versus a waterfall approach. So this is shared knowledge, and this really helps to express that in some programs and some projects. The other thing that we are doing is helping people with experience on certain domains but don't have experience with MBSE and system thinking to get some training and get some experience to be upskilled in the powerful of some of these methods. And the third thing we are doing is running specific programs and projects throughout these techniques so that you can get, as I was mentioning before, you can get the practical experience building things, finding why it's hard, finding what solutions can work, and then building your learning based on that experience. But what I really like to see is that MBSE has been out there in the conversation for several decades. And now I think it's understood this power that systems thinking are equipping us. If we look at the future type of products we build, that they are much more integrated, they have much more disciplines together, and I'm really happy to see that this is now a common shared understanding.
Absolutely. So you talked about software development. A lot of the work that you do related to innovation involves modeling. And you talked about just how much software there is these days and how it adds to complexity. So the digital transformation is performed by an exponential increase of software that interacts. Bugs, of course, will always exist and increase not only in number, but also in its effects just by the interaction between all the pieces. What is your concept to maintain a bug-limited twin software environment?
Well, I think that's $1 trillion question. It's so in everything. So and everything we humans do, there is a probability of making mistakes on that. So we know this, and we've known this for millennia. So we have a lot of frameworks to try and help us in that process. So I was recently learning an interesting data point that software, like the software engineers in 2 years ago, there was more software engineers hired by other industries than hired by the software industry. So I believe that getting all this learning about how you have frameworks that help you to find bugs and critical bugs with automated testing, with continuous development, with DevOps, those things are part now of the knowledge that these software companies have been able to solve and can help us to get there. Then the other thing that we are also see coming as well are tools to help you write certain lines of code and have small components that are very well curated, and you are safe when you plug and play that component. So there is a lot about this know-how on how do you build large, complex software in a way that is modularized. You break it down in pieces that are comprehensible, that can be automatically tested, and that can give you a 99% of whatever threshold you need, that there are free bugs.
Good. Well, we're getting close to the time to be ending. We have had lots of questions. I can see that a lot of interest in this. In fact, even folks are saying, gee, is Acubed hiring, very interesting. So you definitely created an interest in, especially some of our career professionals here. But I want to ask a question that's actually, related not so much to the aviation, but on the space side. But given that you're an innovator and really believe in digital transformation, how would you imagine using digital twins and simulations to design the emerging space superhighway from Earth to the moon and beyond? So, can you think about how you might apply some of what you're learning on the aviation side? How might that transfer then over to the space side of AIAA?
Wow, you are really going to throw that one on me. Well, I don't know. So first principle thinking tells me that eventually you have a system that is going to meet a mission, and then your design process needs to be able to ensure that it delivers the mission. Then if you have something which is out there very far away, and you have less ways to interact with it, then you have to build a lot of autonomy into that system. So, and also we hear about very good projects and ideas around AI and machine learning in space products, because autonomy is going to be really the key enabler of executing some of these missions. Now, what can we keep as a digital twin of that from here? I think it's going to be as good as what we need it to be. Because if we expect to interact less, then probably want to be focusing less synchronization points, but make sure that those points, they have the right information, the right data quality, the right integrity, and this is connected to the question we had before. But I'm just openly thinking about that.
Well, you're a very good straight person, because this afternoon after lunch, our panel is on human and autonomy, and it's very related to what you just said. So everyone should join us to hear more about that. I do want to thank you for your talk, and also the time we've had to answer all these questions. And in appreciation for your participation, we would like to give you this challenge coin from AIAA to remember us by.
Thank you so much.
So thank you, and please join me in thanking Guillermo for his keynote talk this morning.
Thank you so much. It was a pleasure.
And just a couple quick announcements before we leave, because as I said, this is our digital themed day, digital transformation. And so come back here. If you're interested at 10 a.m., we're going to hear from a distinguished panel focusing on addressing increasing complexity in aerospace systems. So this is part of our case, and we will have several experts in digital transformation as part of that panel. Very excited myself to hear those folks address increasing complexity. And then also, after that panel, I'm going to be facilitating one on 4 case studies or success stories on digital transformation. And that starts at 11 a.m. And we're kicking it off with a short talk by General Bartolome, who was the program director for the Sentinel program for Air Force, which is one of the key programs they've done. But we have 4 really great case studies, success stories, so you can join us for that. And then, as I mentioned, after lunch this afternoon, we have another session related to humans and autonomy, which Guillermo played a great straight person for. Didn't plan to do that, but that was great. And then, of course, tonight, you can end your very invigorating day at the Women at SciTech panel. So there's a discussion, social hour. Everyone is invited to that. And then also, today is the day at the Expo Hall that Caltech's Leonardo robot is going to be walking around. So I understand it's around 11:30. So you probably want to catch it. You know, he's on a skateboard. It looks amazing, so it'll be really great to see Leonardo in practice. So again, thank you to Guillermo. Thank you all for your attendance, and see you soon again. Thank you.
Thank you.
Sick of all these lies. Don't care if I capsize. Oh no. Empty hearts and neon lights. They're playing with my mind. Gotta get out of here tonight. Oh, I wanna run off and fly. And I'll tell myself it's fine to be alone. Just to find somewhere that finally feels like home. Oh, oh, oh. I hate all this overthinking. Oh, 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 oh. The more I swim, the more I'm sinking. Take me to a world of silver. No more heartbreaks, tears, painkillers. Take me somewhere unfamiliar. Bring me back to where we started out. Get me out of now. To where we started out. Get me out of now. To where we started out. La 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 la, oh oh. Get me out of broken hearts and starting fights, turning truth to lies. Gotta get up, stop wasting time. Yeah.